trèSci Weekly, episode 17. I'm one of your hosts, Jonathan Ullman, alongside the derivative of e to the x, Tom
the
K.
X. Hey guys.
What's going on?
Doing well?
Doing well?
Yep. How are you, my man?
Not bad, not bad. Actually, that's not true. I have this weird thing going on with my left hand. About a week now.
Oh boy.
Totally numb in these three fingers here.
Ooh.
Not good. Not good.
Might
So I
have to see
either
a doctor,
yeah.
perhaps?
So I either strained it, doing all this heavy lifting, pool company. Maybe damaged a nerve. Maybe pinching a nerve a little bit there.
Workers' comp?
And workers' comp. That, or I have type 2 diabetes.
Oh no.
Which could
From
be
all
horrible.
that healthy eating you're doing.
Both probable. Both probable things here. Kyle's back with us this week.
If you can't tell, the quality is
Way
back to
nicer.
normal.
Way nicer. Yeah. You guys can see all of my pores, my skin fallacies. Today is Monday, May 29th, 2017. It's also Memorial Day.
Yes.
So happy Memorial Day weekend to everybody out there. The unofficial start of summer, Tom.
Yeah, the Memorial Day weekend
Yeah. The start of summer officially
is
summer
the
solstice.
summer solstice.
Yeah,
I tweeted something out about how it works, the summer solstice.
I saw you tweeted that
Yeah.
out. That was actually a really, really cool graphic. I
Yeah.
like that. That was nice. Thank you. Getting a lot of love in the chat. Getting a lot of feel betters. A lot of a lot of Chris is diagnosing me. Chris goes to the doctor a lot, so I can take his word for that. Appreciate that. Welcome to the show. If you're just joining us for the first time, this is trèSci Weekly. This is our weekly video podcast where, Tom and I go through the trending science news topics of the week and offer our thoughts and opinions on that in an attempt to kind of just educate everybody a little bit on what's going on in the world of science.
Yeah, and having a good time with science.
Having a good time while we do it, of course. If you like this, please feel free to hit the subscribe button that you see on our YouTube channel there. If you don't like this, then go away. No, I'm just kidding. If you really like this, you can go ahead and like us on Facebook at facebook.com/trèSci Weekly. You can follow us at twitter.com/trèSci Weekly. And if you're feeling extra generous, you can throw us a few bones over at patreon.com/trèSci Weekly. Anything else that we should mention before getting going this week?
I had a few honorable mentions of stories we're not going to talk about.
Okay.
There was the Big Sur landslide in California.
Absolutely.
I saw that one.
That.
The big mountainside. There was a huge mudslide that basically completely took over the road. And I was talking to Kyle about it, and he said they actually drove on that road on their road trip.
Yeah, I drove on that road too when I was hitchhiking in California. Yeah, so
yeah, it's just a road that's like right along the edge there.
Yeah, the Highway 1.
But nobody was on it at the time.
Yeah, thank God.
Right there, yeah, or they would have been dunzoed.
They would have been in the Pacific.
Yeah.
Pretty much. So
that was a cool story.
That's pretty interesting.
You got to remember that whatever you're doing, the Earth still does its thing. You know, it doesn't care where you're driving.
Yeah. We couldn't fit that into the schedule. We've already talked about a landslide in California on one show. Yeah. So
I mean, can't cover every landslide.
No, I'm just kidding.
And then nothing else that I wanted to cover in particular, but I had a few other stories we're not going to talk about on our Twitter.
Yeah,
if you want to check out more science news.
I saw you tweeted out the graphic of that star system that people potentially think could have alien life, the alien megastructure. Yeah, and how it could potentially be a series of asteroids, much like the Trojan asteroids in our solar system. So I thought that was pretty interesting. Didn't want to get too far down the rabbit hole on that since that news story kind of broke before we even started trèSci, so I didn't want to be like, oh yeah, there's this thing by the way that we never covered, and now we're giving you an update on it. But I guess we could have.
And then the other cool one I saw was that the sperm from the mice, they kept it up in the International Space Station for a year, brought it back, and it was successfully used to fertilize, and they made babies with it.
Yeah.
So your sperm can survive in space for a little while.
Space babies, dude. Yeah. They're coming.
It's possible.
They're coming.
Yeah, but other than that, nothing too crazy.
Yep. So 4 stories on the docket this week, which may seem like a few, but I figured we can actually talk at length about some of these topics. So, without further ado, Tom, let's roll up our sleeves and get right on into the news there. First story, number 1. On Thursday, May 25th, NASA held a teleconference announcing the first wave of scientific results from the Juno mission, an orbiter designed to investigate the planet Jupiter. Juno launched in August of 2011 and arrived at Jupiter on July 4th, 2016, last summer. And it has completed 6 polar orbits, or perijoves, to date. So polar orbits, much like we've been talking about the Cassini spacecraft, how it has gone into a polar orbit around Saturn. Polar orbit means that it's kind of looping around the North Pole and South Pole instead of going around the equator side of Jupiter.
At the poles.
So it runs from the bottom to the top, from the top to the bottom. And yeah, so it's been doing this for about a year now, and we're finally getting our first scientific results from these flybys.
And it takes a little while to get back to where you want to be in the orbit, right?
Correct.
To look at it. So that's why you get these news periodically. It's not like NASA's holding out on you and then releasing the story just, as it flies by, they get more info and then they put it out there.
Although they
do hold on to it every once in a while.
Yeah, they do hold their cards sometimes to sort of make a bigger splash. But I like that kind of stuff. I think that's cool. So, according to Scott Bolton, Juno's principal investigator, the first year of exploration has unveiled that Jupiter is a much more complex system than originally thought. Right? So, for many years, scientists have thought that Jupiter's surface, very interesting, right? We have these bands and belts that we can see visibly even through a small telescope. And they figured once you get kind of below that top atmosphere that things would probably just be uniform and not much interesting dynamics going on in those layers. But now we've got these instruments that are specifically designed to look
through the atmosphere a little bit.
Yep, and we're finding much more complex systems there than we originally thought. So if we can go ahead and bring up the first picture there, Kyle. Let's take a look. All right. The first image shown is a composite image of Jupiter's North Pole, showing an abundance of cyclones and anticyclones, revealing that from the poles, Jupiter, quote, doesn't look anything like it does from the equator, end quote. So
these are similar to what you would see on Earth, except these are a lot bigger, a lot more spread out. A cyclone or an anticyclone, that just depends on which way it's spinning.
Right.
And it's just it's basically a giant gas hurricane.
Yeah.
You can almost think of it that way.
Well, lots of them.
Lots of them, yeah. That's what each one of those.
And some of these are the size of the Earth, even.
Yeah, and bigger.
Right.
Some of them, yeah.
We'll also notice the blue hue to the North Pole there, and according to that same teleconference, that is not just a photographic effect, that is probably actually there. Again, these are some of the first images looking down on the poles of Jupiter that we've ever gotten. So really, really nice.
Yeah, it looks like nothing you've ever seen of Jupiter.
Yeah.
But nobody's ever really known what it looks like.
Yeah.
And it's pretty intense, honestly. That's quite a lot going on there.
Yeah, definitely. I mean, the resolution being that we have these, nice high-resolution cameras that we can equip our spacecraft with, really kind of bring out the striking features. This is a composite image, so that means that, of course, at any given time, if you take a snapshot of Jupiter's North Pole, you're going to get a sunlit area on the side that's facing the sun and a dark lit area, the night side of Jupiter.
Put the two together.
They stitched it all together, right, basically to give us total illumination of the North Pole at one time, and we can see.
But this is what it would look like. James says, is that in the visible light spectrum? And I believe it is, yes.
Yes, it is, yep. So this is what it would look like to our eye. Maybe not as drastic of a deep blue color to our eye, but certainly that blue hue would be there, which is pretty fascinating.
Yeah, pretty amazing picture.
So from this picture, and we see these cyclones and anticyclones, the question going forward will be, are Jupiter's storm systems at its poles stable, like the Great Red Spot, or are they dynamic and change often? Right? So Jupiter has that one huge storm
the red
system.
Spot. Most people are aware of that one.
Yep, that's been there for hundreds of years.
Since we've observed Jupiter, right?
Yep.
Basically.
Yep. So it's pretty stable as far as storms go, and
we were talking about what would make storms stable on Jupiter too.
Mm-hmm.
So they have the big red spot. It's basically an Earth-sized cyclone that's been there for hundreds of years. So when you think about cyclones on Earth, as you get a hurricane, what happens to it? Like, why does it go away? Well, eventually it hits land and it loses its energy, the warm water that's supplying all the energy for the storm. But on Jupiter, we're not getting the energy from the sun, and we're not losing any energy as we go on land because it's all gas, and it gets its energy from underneath it, from the interior of Jupiter. So it seems like to me that there's not really a mechanism to like shut down these storms, as you know, there's not like an easy way for them to lose their energy.
Yeah.
It seems like I would expect these ones would be they would be there for quite a long time.
Yeah.
Maybe not as much as that giant red storm, but I think these would be on the scale of many years at least.
Yeah,
probably.
I agree.
Looking forward.
And what's cool is as Jupiter completes more paths, more polar orbits around
we'll be
the
able
North
to
Pole.
track them, right?
Yeah, we'll be able to compare, okay, on this date, we had a cyclone here, we had an anticyclone here. Now we come back around on this date. Did they move? Are they still as strong as they once were? So, yeah, that'll be interesting to see going forward.
Yeah, I think at first this image is just kind of a shock, like, wow, there's a lot going on that we were unaware of.
Yeah, really cool.
Now we'll just track it and see what happens.
Yeah. All right, so moving on, let's bring up the next photo if we may, Kyle. All right. So the next image is a visualization of data collected from Juno's microwave radiometer, an instrument that allows Juno to peer into the interior of Jupiter's upper atmosphere at depths of up to about 350 kilometers. Quote, in the cutout image to the right, orange signifies high ammonia abundance and blue signifies low ammonia abundance. Jupiter appears to have a band around its equator high in ammonia abundance with a column shown in orange. This is contrary to scientists' expectations that ammonia would be uniformly mixed, end quote. So, this is Jupiter as we would normally see.
Yeah, this is the picture we've been used to.
Exactly. So, in this little inlay, right, to the right-hand side, we are looking at from the very top of the atmosphere to about 350 kilometers inward into the interior, and measuring the ammonia abundance that's there. And what the Juno science team found interesting is that you have right at the equator this band of high ammonia concentration.
As opposed to it just being spread out uniformly.
Exactly.
Which they thought it was.
Right.
Yeah.
And we have no idea why. No idea why that's like that. It could be that band goes all the way down deep into, further than the 350.
Yeah, and it's just part of the structural of the atmosphere for whatever reason.
Could be. Hopefully we'll be able to get more scientific results from the other instruments on board Juno that are going to look further into the interior to see if that's the case. The other interesting thing here is that while that column of high ammonia abundance seems to correlate to that equatorial belt there, that belt that we see right in the middle, the other kind of low concentrations and high concentrations do not sort of correlate to
those other layers.
Yeah, to the optically visible layers that we see there. So totally weird. Totally weird.
Some more underlying physics down in the atmosphere that we don't know about.
Yeah. So we don't have any sort of even guess as to like what that, if it's an upwelling, if it's if it's just a stable, I don't even know, stable amount of pressure there. Like, no clue. So that's pretty interesting.
So before we move on, James had a comment that we could probably look at the storms that aren't stable and maybe learn about what's underneath them. Maybe learn more about the atmosphere of how the storms are forming and dissipating if they do.
Yeah.
And then Carrie Kalita asked, do we know the constituent gases that make up the atmosphere at this time?
We do. I would have to look them up.
So it's a lot of hydrogen and helium, right?
Absolutely, yeah. So let's take a look. Jupiter's atmosphere. Mostly molecular hydrogen and helium in roughly solar proportions. So about 75% molecular hydrogen, 25% helium. Small amounts of methane, ammonia, hydrogen sulfide, and water.
And that's basically what it's made up of?
Yeah. So that's a great question. All right, moving forward. Following the showing of this image, Scott Bolton briefly mentioned that the initial gravity field mapping of Jupiter's deep interior to determine whether or not Jupiter has a compact core has been evaluated from Juno's first pass, and the results came back quote-unquote fuzzy, indicating that the core is probably large and diffuse.
So, meaning it doesn't technically really have a core that has like a solid structure around it.
Right.
It more probably just has higher pressure that sort of blends in as you move out with the rest of the planet.
Yeah.
Not a defined core.
So the interior structure of Jupiter is really interesting. Those were kind of the two competing theories. It's like, okay, does it have a solid rocky metallic core that everything kind of accreted onto, or is it really just gas that is such high pressure at the center that it acts like a metal, that it acts like a solid
at those crazy pressures?
We're thinking that it's probably the latter now, but we've only studied the first pass of that.
Yeah.
So that
nothing concrete.
Nothing concrete yet. That those will be probably better determined on future passes. Yeah, and in the teleconference, they kind of shrugged that statement off really quickly. It was like, okay, yeah, so it's kind of fuzzy. All right, now we're gonna go to the next thing. So that's what we're gonna do too. So if we can bring up the next photo there, Kyle, we got lots of photos here. This should actually be 3. Jupe 3. So what we're looking at here, to discuss Jupiter's magnetic field findings, Jack Connerny, Juno's deputy principal investigator, provided a graphic showing how Jupiter had pockets of magnetic field strength that are both stronger and weaker than expected from previous distribution models. This could indicate that Juno's magnetometer is observing a region very close to the dynamo where the magnetic field is being generated, which may take place somewhere just above the molecular metallic hydrogen transition line. So, this graphic here, we're seeing basically an area where there is the strongest north magnetic field and the strongest south magnetic field.
It doesn't exactly line up with the poles of the planet.
Right.
It's a little bit offset.
Similar to Earth in that regard. And the black streak that you see kind of going down the middle there, that was Juno's flight path.
Okay.
And it measured, using the magnetometer, basically kind of more regional areas of what that magnetic field would look like, right? Kind of the background rainbow overlay is the theoretical model, and then these 5 pockets of these little kind of hexagon shapes that are all strung together.
Got the data from.
Exactly. And so you'll see kind of at the North Pole there, they expected it to be pretty high in Gauss in the northern magnetic field strength, and it's a little bit weaker than expected there. Then a little bit further down or further south, it's a little bit stronger than they expected. Again, more towards the equator, stronger than they expected.
That's quite a bit stronger, in the middle.
And then kind of right dead center in the equator, much weaker than they expected. And then again, all the way down towards the south, I'm sorry, in the middle, stronger in the reverse polarity, and then in the south, weaker. So, very odd dynamic magnetic field going on.
Yeah, definitely more complicated than we know of.
Yeah. And you can see that little kind of blue circle there. That, I'm guessing, is the theoretical model for the Great Red Spot.
Okay.
I would imagine. But, so that's pretty interesting there. So if they're looking at that transition area, right, where the molecular hydrogen changes from being kind of just acting like a gas to being so compact and pressurized that it starts acting like a metal, well, that's pretty interesting, because then that could be where the field is getting its strength from, right? Yeah. We think here on Earth that it's caused kind of by some friction between our liquid core and our solid core, right? Yeah. That's what generates the magnetic field on Earth. Could be that this is what we're looking at,
that
something similar.
To solid transition.
Yeah. So there might be some kind of friction between those two, that transition line that causes it. And it could be that Juno is looking right at that depth, right there.
Yeah, so that would be where it's generated. It might be a little bit harder to look at exactly what it is if that's the exact place where it's being generated.
Right.
It's hard. It might be a little bit harder to observe there.
Right.
So they'll probably look for it at different depths and things, I would assume.
Yeah. So that's cool. And way back on one of our early episodes, we discussed the kind of the studies that are going into trying to figure out at what pressure hydrogen does start to act like a metal.
Oh, yeah. Mm-hmm.
And how there were some findings that people were kind of questioning the results on and whatnot. Well, this is why it's important to get that right? Because now we're looking at a real application to those studies.
Yeah.
And that's kind of a hotbed of research right now. So it'll be interesting to compare the theoretical models and the actual data that we get with Juno to what's going on in laboratories where they use a diamond anvil basically to squeeze hydrogen at such high pressures where it acts like a metal. So that'll be really cool. All right. Moving forward, next image, or actually next video, if you don't mind. Continuing on with the magnetic studies. A short GIF video of Jupiter's southern pole and its auroras. The green and white hues show where energetic electrons precipitate or fall in towards Jupiter, interacting with hydrogen to emit the auroral glow, much like we see here on Earth, right? The aurora borealis or the aurora australis that we can see here on Earth. And what's interesting here, Tom, is the red hues indicate electrons that are actually being pulled out of Jupiter's atmosphere. Right? So they're going in the opposite direction to generate those lights, basically, those northern and, in this case, southern lights. So,
and that's not how the northern lights are made on Earth. We don't see that. So this is a completely different phenomenon that also creates a northern light effect.
Yep. And the mechanism by which those electrons get ripped out of the atmosphere, still unknown. So for every kind of interesting thing we find here, there's a new mystery to solve, right? Which is why I love these exploration missions. I think they're really cool.
And Chris says the screen's black right now, because I guess it doesn't replay the GIF over again. I'm not sure.
Oh. Let's see if we can play it one more time for you guys.
And then Carrie asks, what's the lifespan of the Juno mission?
The lifespan of the Juno mission is, I think it's going to be only a few years. I don't think it's going to be as long as Cassini was. Let's take a look on that. But then again,
as we discover more, I guess you can't know for sure.
They can extend it, but it'll depend on the fuel supply also. Mm-hmm. We can check on that as well. Let's see. Not the Juno film. Get out of here, Michael Cera.
That's where the girl has the baby, right?
Yeah.
Juno.
It's actually a pretty good movie. I like that movie. So the mission duration is 7 years total, but that includes the
time
flight
to get there,
right out
which
there.
took
5 years. So 2-year mission studying Jupiter. So, but we'll get a lot of
good
info out of those 2 years for sure. Cool.
All right.
Moving on. Next picture, if you don't mind. Heidi Becker, Juno's radiation monitoring investigation lead, showed off an image from Juno's Stellar Reference Unit depicting a view of Jupiter's main rings in the foreground and the constellation Orion in the background. So this is pretty cool. This was just kind of a unique perspective of what the Juno spacecraft kind of looks out towards in terms of keeping it on track in its orbit. It uses stars as references.
Stars,
yep. And so, you see Betelgeuse, or Betelgeuse as some people pronounce it, in the background, and then the 3 stars of Orion's belt kind of at the bottom there. And then that kind of slash across the middle there, that's Jupiter's rings. And yes, Jupiter also has rings. Not many people know that, because
a lot of planets have rings.
Yeah,
surprisingly.
Yeah. Not as grandiose as Saturn's rings, of course, but a ring system nonetheless. So that's pretty interesting there. And moving forward again, next image. Finally, Candy Hansen, Juno co-investigator, shows some astounding high-resolution images of Jupiter's cloud tops. So we get a 14-image mosaic that gives a beautiful representation of what Juno sees along its 2-hour pass from North Pole to South Pole. And this is really cool. Yeah. I like this a lot. This would make a really nice
big
poster. Yeah. I should just tear down the trèSci poster and put this up instead. And then we can zoom in, basically. So we'll hit up the next image. And I actually don't know if you can zoom in on this image, Kyle. Can you do that?
Get it a little deeper.
Yeah. Does that work for you?
And then James asked 2 hours north to south.
Correct.
And he said that's like 1 billion miles per hour.
Yeah,
it's going quick.
It's going fast. It's screaming across Jupiter there.
Close.
Cool.
All right. So when zooming in, we can see details such as these tiny white clouds, which are actually each about 50 kilometers across in size. The clouds are almost certainly made up of ammonia and water ice, and so it is likely snowing in some sense on Jupiter.
With ammonia and ice snow.
Yep.
Be interesting to actually be in.
Yeah. So that's pretty cool there.
Yeah, it's quite the image.
So we see this kind of all across Jupiter, right? Northern hemisphere, southern hemisphere, lots of areas where these kind of pockets of top clouds are accumulating, basically. And so there's what the teleconference panelists said would be snow, right?
Yeah.
Snow or hail or some sort of precipitation. So more unexpected results. Pretty cool. So just to kind of conclude here, Juno's orbit is such that it passes by the upper atmosphere of Jupiter every 53 days. On July 11th, Juno will make its next pass and is expected to fly directly over Jupiter's Great Red Spot, a storm larger than the size of the Earth that has persisted for at least 350 years. An image and graphic credit goes to NASA, JPL Caltech, Southwest Research Institute, MSSS, GSFC, Harvard, Betsy Asher Hall, Gervasio Robles, Gerald Eigenstadt, and Sean Duran. So lots of people.
For all those beautiful images, yeah.
Yeah, lots of credit to dole out here, because a lot of the image processing, Tom, is done by amateur astronomers. So Juno's database is open to the public. You can just log right into NASA's website, and you can download the raw images and sort of stitch them together and process them in ways that you can basically do more science with them.
Yeah.
And NASA's really relying on the public to do a lot of this. They kind of cut down the cost of the Juno mission by not hiring people to do this work on board as the team. They're kind of relying on people to do that dedicated work. It takes a long time actually to process these images because there's a lot of data in these high resolution photos, and so the credit is well deserved to those guys out there that are guys and gals that are doing that. So thank you for the wonderful images there. How are we doing in the chat?
People are just loving the Jupiter pictures. Yeah, loving them.
They are awesome. Really, really cool. Can't wait to see more.
Yeah,
and we'll get plenty more for the next 2 years. At the end of the teleconference, Tom, there was a really great Q&A session, and one of the last questions asked, I don't remember who asked it, unfortunately, but they asked if there would be comparative studies between Juno's polar orbit and Cassini's kind of grand finale polar orbits that are going on. And Scott Bolton said, of course, there will be. In fact, many people on the Juno team are scientists on the Cassini team.
Okay, makes sense.
And comparative studies between those two gas giant planets will provide the best insight as to how our solar system formed, right? We'll be able to see one way versus the other, right? Okay, so this is how Jupiter formed, and it's different from Saturn in this way, this, that, and the other way, and it's similar to Saturn in this, that, and the other way. And I wonder, Tom, if that will kind of prompt new investigation into the planets Uranus and Neptune following the Juno spacecraft.
We may see those.
I hope so. Uranus and Neptune, by far the least studied planets in our solar system. By far.
Yeah.
The only spacecraft that have flown by are the Voyager spacecrafts.
On its way to Pluto.
No, on its way out of the...
Those ones went,
out of the solar system. New Horizons that went to Pluto did not pass by because they weren't near each other in their orbits at the time.
Didn't even get a chance.
Didn't get a chance to see anything. So that would be cool, you know? Since we're finding so much uniqueness in Jupiter where we didn't think we would, imagine what we would find in Uranus and Neptune now.
Yeah, who knows?
You know, like lots of interesting stuff going on there. I would bet, you know.
Yeah.
And one of the biggest mysteries, of course, is why is Uranus on an axial tilt of almost 90 degrees, right?
Like what happened to it?
Yeah. The North Pole of Uranus basically points directly at the sun, and so its ring system goes up and down as opposed to this way. So what happened? Did it get smashed by something else, or
but it's a gas planet too, so
how does that even happen?
Not sure.
Yeah. Pretty cool stuff.
So just to address one question, Carrie in the chat says, as Earth has a day, Mars has a soul. What does Jupiter have? So Jupiter takes about 10 hours to rotate once, and it's actually the fastest rotating planet in our solar system.
Yep.
And it happens in about 10 hours.
Yeah, I don't know if there's a specific name for it.
I don't know. Not sure.
Possibly. I'm sure there is.
But yeah, so that's kind of what allows these giant cyclones to form. It's spinning extremely fast, and that gives it a lot of the rotational energy it needs for these cyclones to form.
That's exactly right. Yeah. Cool.
Sweet. That was a lot of Jupiter.
A lot of Jupiter. Yeah. I mean, you know, major news about the largest planet in our solar system. And of course, the more we know about the largest planet in our solar system, the more we can extrapolate to other solar systems, which is the goal. You know?
Yeah.
That's cool. Moving onward, number 2, we'll get into science policy a little bit here, Tom. On Tuesday, May 23rd, the Trump administration released their full 2018 budget request to Congress. Elaborating on the preliminary budget outline that was put out back in March, the plan continues forward with the slashing of funds to most of the major agencies in favor of redistributing resources, $639 billion, in fact, Tom, into the Department of Defense. Emily DeMarco and the ScienceNews.org staff put together a really nice chart outlining how the science agencies would be affected by the Trump administration's budget if it were to pass in Congress as is. So we'll take a look at that in just a moment if we could. Kyle will bring that up for us. So the chart reads, Budget Request Fiscal Year 2018. The President's proposed 2018 budgets for select science agencies in billions of dollars. Here, Tom.
That's what we're looking at.
That's what we're looking at. So we've been covering this kind of as it's come out. We covered the
2017 budget.
Yeah, we covered the initial 2018 preliminary budget back in March. We covered what Congress settled on for the remainder of the 2017 fiscal year, and now here is the Trump administration's kind of next wave of
their proposal again.
Yeah. So this isn't going through just yet. Congress has to approve this, but this is what the White House wants, basically.
Yeah. So the cuts look pretty drastic, and we're hoping again that Congress sort of, doesn't allow this to happen. We're kind of hoping on the system to work again.
Yeah.
But I mean, how many times do these cuts need to be proposed before we realize they're a little bit ridiculous? Right?
Yeah. So
we'll see.
Let's go through it quickly. For the EPA, the Environmental Protection Agency, they're poised to lose 30% of their funding from this year to next year. Specifically, their Science and Technology Department would lose 37% of their funding. The FDA, the Food and Drug Administration, would be poised to lose 30% as well, cutting down from $2.7 billion to $1.9 billion. The caveat there is that does not include user fees. So what that means, Tom, is if you are proposing a new food or drug to be evaluated by the FDA, you pay a fee, basically, in order for the FDA to do that work. And so basically what would happen in this case is the 30% budget reduction would just fall onto the users, right? They would have to pay to make up that difference. And so that's going to, of course, fall on the consumer, right?
Yeah.
To pay for the rest of that. So that's great. NIH, National Institute of Health, would be poised to lose 22% of their funding, specifically 21% in the National Cancer Institute, 23% in the National Institute of Allergies and Infectious Disease. NASA would be poised to lose only 3% of their funding, which is nice for people like me who love space. 9% of that would come out of the Earth science programs. So again, cutting down on looking at our own planet, which doesn't make much sense for studying other planets. But planetary science would actually be poised to increase by 4.5%. And this is the only kind of agency specific that we see an increase in that Science News chose to show us here.
So just before we move on, just so we're all on the same page, Matt said, weren't we talking about this a few weeks ago? So we were talking about the budget, but we were talking about the proposed budget for the rest of the 2017 year. And then Congress came in and they didn't do the drastic cuts. And now this is the proposed budget for 2018.
Correct.
And it has a lot of the large cuts again that we're trying to explain now, that these cuts should be not as drastic once it gets through Congress, hopefully, like it was for the rest of the 2017 year. But it sends a message, right, to a lot of these agencies about where they stand, I guess, under this administration.
Exactly. So, yeah, just to finish up really quick, NOAA would be poised to lose 16% of their funding. Oceanic and Atmospheric Research would be poised to lose 32% of its funding. National Weather Service would be poised to lose 6% of its funding. NIST, the National Institute of Standards and Technology, would be poised to lose 23% of their funding. NSF, the National Science Foundation, would be poised to lose 11% of their funding. DOE, the Office of Science, would be poised to lose 16% of their funding. That's basically what funds Brookhaven National Labs facilities.
Carrie mentioned in the chat that B&L will experience large cuts.
Oh, yeah. Yeah, 16% is no joke. The CDC, the Center for Disease Control, would be poised to lose 17% of their funding. USGS, United States Geological Survey, would be poised to lose 15% of its funding. And USDA, the United States Department of Agriculture, particularly the Agricultural Research Service, would be poised to lose 22% of their funding. And all of this would be made up either in trimming down the deficit or being redistributed into the Department of Defense to go into the military. So, again, like Tom said earlier, this just kind of reiterates the White House's stance on what
is being done in a lot of these organizations,
yeah,
I guess.
On how they kind of view scientific research in this country, and doesn't look good, right? Definitely
Once
doesn't
again,
look good.
Yeah. And Karen Riley mentioned in the chat, she said this will lead to privatizing of research, and that's kind of an issue that a lot of people have been talking about, that if something like this were to happen, like if this budget were accepted closer to these numbers as opposed to how 2017 is, that the hope would be that the slack gets picked up somewhere else if somehow there were large percentages cut. But it doesn't seem like there would be a nice smooth transition to the privatization of a lot of these issues, because a lot of them aren't lucrative in themselves, but we see a more overall importance to them in society over the long term than maybe a business would see in short-term gains of getting into this sort of research.
Yeah.
Make sense? You know what I'm saying?
So we've talked a little bit about how the privatization of some of these agencies could kind of take the place here, and that works to a degree, right? I mean, we look at companies like SpaceX, right, that are pioneering and pushing NASA in a sense to do better than they might have on their own, because there's a competition there. And I think that's great. Right?
That is a great dynamic.
I hope SpaceX makes a lot of money going forward into the future, because they're awesome. But would SpaceX be poised to build a Jupiter orbiter like Juno? Probably not, because there's no money there.
Yeah.
Right?
Even though there's a lot of amazing knowledge to be found out about it.
Yeah. The governmental agencies that are studying scientific research, they do it just because it furthers our knowledge on certain topics. And I think that's really important and something that we can't lose sight of.
That it's not that a lot of these agencies function well because they're not focused solely on the dollar.
Right.
And
you know?
That's sort of the nature of some of this research.
Yeah.
So it can't all just be nicely transitioned to more of a private industry.
Yeah. Like, is it important for NOAA scientists to study lightning? I don't know. Like, maybe not in the sense of a business plan.
Yeah,
but
like
it's
to make returns off of studying lightning, but
it's cool.
Yeah,
like,
things we should know, right?
It's things we should know. So yeah, so this just spells disaster, and a lot of people in the science community have been saying that this would be a disaster should it go through.
Sort of the same way we talked about it with the 2017 year.
Yeah. The other thing I want to bring up here, Tom, is that, so we know that the ripple effect of things like the March for Science take some time, right? But we can immediately see, right? We had this whole weekend of scientists and science educators and researchers taking to the streets worldwide.
Yeah, across the whole world.
To fight against what the preliminary budgets said about science. And here the Trump administration
preliminary budget
says, we don't care. We don't care that you guys are fighting against this. We don't care what you have to say about this. We're cutting all of these agencies. And that's really interesting in the sense of like, well, no administration has ever done this to the scientific community before.
Yeah, like this, yeah.
I wonder how now the scientific community will respond to something like this, because I'm not going to take this sitting down. You know, it's like, this is going to devastate our country. Like, are you kidding me? No way can we just take all of the resources out of these agencies and put it somewhere else.
To just go the same way they are.
Yeah. No way. So
Carrie in the chat says contact your representative. That's never a bad idea.
Yeah.
The more people that are just saying these things, the harder it is to ignore them.
Yeah, absolutely. And, you know, we've seen an example of Congress not taking this nonsense and just kind of saying, okay, yeah, your wish is my command, right? Yeah. They seem to have their head on their shoulders straight a little bit better in the sense of kind of making sure that agencies that are doing research and doing scientific work will have the funds that they need to continue doing them. But, you know, they're only going to act if we tell them to, right? So, yeah, contact your local representatives. Make your voice heard, right? share this with people.
Make sure people know.
If you didn't know any better, right? You might not know that all of this money is going to be cut out of scientific research. So make sure that this is widespread news. So in related but unrelated news, Tom, it appears that we did not, I guess, get the point across with the March for Science that topics like climate change are important. And so the question is, well, if we can't do it, who can kind of change the mind of the president? And it appears that perhaps other world leaders, like the world leaders that were at the G7 summit in Taormina, Italy, may have actually driven the point home, right? So according to Trump's economic advisor, Gary Cohn, on the topic of climate change, the president's views are evolving, right? So, quote, "He came here to learn. He came here to get smart. His views are evolving, which is exactly as they should be. His basis for a decision ultimately is going to be what's best for the United States," end quote. The decision on whether or not the United States will continue to support the Paris Agreement, an international accord that attempts to halt the rise in global temperature to, quote, "well below 2 degrees Celsius above pre-industrial levels, and to pursue efforts to limit the temperature increase to 1.5 degrees Celsius above pre-industrial levels," is still up in the air. President Trump tweeted out on Saturday morning, quote, "I will make my final decision on the Paris Accord next week," end quote.
So we're just waiting on the next tweet, I guess.
So we're just waiting on the next tweet.
See what happens.
So I'm really glad that other world leaders put it in his ear that he has to address this and he has to do the right thing here, because we're not, I guess, loud enough.
Because if the United States bails out of the Paris Agreement, it's like...
it's basically over.
It's a joke, It's like, well, everybody do whatever you want, I guess.
Yeah.
You know? Like, honestly.
Yeah.
So, it's a little scary.
Yeah. So, good on them for...
making
that point. What scares me is that he's still mulling it over. There's really not much to learn, right? He came here to learn. He came here to get smart. I mean, it's like pretty straightforward, there's not really a whole lot you have to think about in order to stay in the Paris Agreement. And so my fear is that he's waiting a week to sort of brush it off, that he's going to say, no, we're not supporting this anymore.
We thought about it.
Thought about it, but I didn't want to make the announcement at the summit and get yelled at by Angela Merkel. So
we'll see.
We'll see. We'll update you guys with that next week, hopefully. How are we doing in the chat there, Tom?
Doing good. Kayla says, "What a world we live in."
What a world indeed. Shall we move on?
Yes.
All right. Number 3. Figured we might lighten the mood a little bit after that last news.
Yeah.
So it's getting a little heated, getting a little fired up there. So number 3. Janelle Shane, a researcher at UCSD, recently attempted to use a neural network AI to invent new paint color names. Quote, "For this experiment, I gave the neural network a list of about 7,700 Sherwin-Williams paint colors, along with their RGB values." RGB is red, green, blue color values, Tom. "Could the neural network learn to invent new paint colors and give them attractive names?" End quote. The answer, hilariously, is no, not really. By tweaking the creativity settings of the AI, we're treated to some pretty exotic names. So I thought it'd be fun to kind of go through them together. So Kyle, if you would like to bring up the first set there of paint names, we see just some nonsense words, right? They don't even really make any sense. Like Wiltbizd, right? It's kind of a greenish color. Bilf Gom Glazd, Gorl Patty Hecht, Woollybaff Ronder Wiley, Iroi Sermout, and Dondarf. So that's just a whole bunch of nonsense.
If you went into Lowe's and you were trying to paint your living room, you probably wouldn't pick out the Dondarf.
Probably not.
I had recently done some painting, and the name of the paint was Old Map, and it was kind of like the back of like parchment. So it was actually like a really good name for it. And I was like, oh, it's because those are people's jobs. They come up with the names
for that.
Yeah, to make them be like a hue that you would want to use. So that's their job.
Yeah,
and that's funny that trying to use a computer program, this neural network, trying to like use it. It's kind of funny that it came up with these ridiculous names.
Yeah. So I guess the challenge was trying to get the AI to recognize the color and the name that we associate with the color, and then
come up with
come up with something clever for it. So it got a little better as things went on. If we want to move to the next set of colors that Janelle tried here,
he changed a little bit of the parameters, right? Yeah.
Right. So the next set we got Styx Red, Coral Gray, Rover White, Corcountinitial Orange, even though that's not orange at all, Ghastly Pink, Power Gray, Naval Tan, Bacco White, Horrible Gray, Homestar Brown, Snader Brown, Golder Cram, Herky White, Burf Pink, Rose Hork. These are just ridiculous. This was really just an excuse for me to say a whole bunch of nonsense words on the show. Going a little bit further, the next set, we got Black Hand.
And it's not black.
It's not black. Gray Pubic. It's not gray. Fairy Purple. Not purple. Ice Gray. Gray Pock. Burial Blue. Stoomy Brown. Nice Stoomy Brown, Tom. And finally, the last set that we tried out here, we got Cat Babel, Bunflow, Raunching Blue, Bank Butt, Caring Tan, Stargoon, Sink, Stummy Beige, Dorkwood, Flower, Sandan, Grade Bat, Light of Blast, Grass Bat, Sindus Poop, Dope, Testing, Stoner Blue, Burble Simp, I can't read the bottoms here, but something Bean and Turdley.
Yes, Stanky Bean.
Stanky Bean and Turdley. So what a mess. Man, that's funny as heck.
So I guess those people who come up with paint names are safe for now.
Yeah.
Until we come up with a better system.
Exactly. Conclusively, Shane writes, quote, "In fact, looking at the neural network's output as a whole, it is evident that, 1, the neural network really likes brown, beige, and gray, and 2, the neural network has really, really bad ideas for paint names," end quote. So the entire process is documented on Shane's Tumblr, which you can follow at lewisandquark.tumblr.com. And there's a lot of really hilarious...
Yeah, he does a lot of other stuff with the neural network.
I think it's a she.
Sorry.
Yeah. It's okay. The neural network naming different Pokemon and naming different action figures and things like that. So really funny stuff there. Moving forward, last story, Tom. Number 4. Scientists continue to shed light on the catch-22 of making research on rare and endangered species available to the public. In a recent essay titled "Do Not Publish" by Australian conservation biologists David Lindenmayer and Ben Skeely, published in Science magazine, the authors illustrate, quote, "the dual-use research dilemma in which research can have both substantial positive but also negative impacts," end quote. On the one hand, as research publications have modernized, changing over from papers chronicled in university libraries to online databases, free access to this research has become increasingly available to scientists worldwide, allowing for more frequent collaborations, better repeatability techniques, etc., etc.
Yeah, we talk about it all the time, how important it is to allow your research to be the knowledge out there to collaborate, and just how important it is.
Open source is the way to go. I mean, we talked about it with Juno just at the top of the show, basically.
That's an important part of what they do.
Mm-hmm.
But here's an example, a rare example, when it's actually could be a bad thing.
Right. But on the other hand, especially in the fields of biology and biodiversity, free access to detailed information about rare and endangered species means that poachers and collectors gain access to hunt the same species scientists are discovering and researching. Quote, "Poaching has been documented in species within months of their taxonomic description in journals. For example, more than 20 newly described reptile species have been targeted in this way, potentially leading to extinction in the wild," end quote. Lindenmayer and Skeely urged conservation scientists to share information about where a research species is found only with government agencies, hiding that information from the public. and it seems many scientists are inclined to reluctantly oblige. According to a follow-up report by Science Magazine's Warren Cornwall, researcher Mark Alia discovered that within a year of his 2012 paper announcing the discovery of the Borneo earless monitor lizard, Lanthanotus borneensis, for the taxonomic name there, Tom, online search results revealed that the lizard was already being trafficked by animal collectors and suppliers. So we can bring up a snapshot of that lizard just to show you guys what we're talking about. Pretty cool looking lizard, actually.
But yeah, so who would have thunk that sharing information about it leads directly to just giving poachers more information about these rare species that people are concerned about?
Yeah. So really kind of crappy.
Yeah.
There's no way to
really put it.
Yeah, there's no other way to put that. Image credit for this image goes to trèSci Lee in the Wild Borneo Photography Wikimedia. Yeah, I don't really know how I feel about this because obviously, kind of as a generic or a generalization, I feel like information and research should be available to the public.
Yeah.
Because you might inspire somebody to learn more about these topics that, otherwise wouldn't know about them, right? I mean, all the information that we give you guys comes from scientific reports that you and I read.
That are made public, yeah.
Yeah. Otherwise, if that information was private, we couldn't tell you about it, and that would stink,
Yeah.
So, but if poachers are going to use this information to hunt these animals,
yeah, so
it can't really be made public.
Yeah, what I was reading about, hopefully what they'll be able to do is put out all of their findings and just limit the locations that they talk about to just a broader area, as if instead of listing an exact latitude and longitude or a part of the Republic of Congo, if you just list the whole Republic of Congo.
Yeah.
People still may be inclined to poach it a little bit, but at least it's not a specified area. So that was saying one way to kind of help it out a little bit.
Yeah.
But it does stink that people are out there looking for this type of information to abuse it.
Yeah. It's just play Pokemon. If you're really trying to collect reptiles, just play Pokemon. You know what I'm saying?
Yep, but whenever there's $1 to be made, there's a person out there, right?
Absolutely. All right, so that's all the news, Tom. I know we're kind of towards the end of the show.
We're a little quick on time, so we can go. Tom's Corner will go a little quick, but we'll go through it.
Yeah, I mean there is no real time limit to this show.
That is true. We could be here all night.
Yeah.
Nah.
Kyle's eyes is wide. No.
Yeah, it is sad about the poaching though. So, if you wouldn't mind bringing up the first image, the only image. So, this image, give credit to Ackerman and Gruber for Nature. This is from a study I was reading about. I'm not going to go too in-depth into the study, but as you can see in the picture, they're basically trying to study all the conditions in an office building and to try and optimize the office work setting as much as possible. So what they did was they took a medical records office, took their whole floor, put them in a new building where they can change whatever they want, the way the walls are, the speakers, what's coming out, the vents, the lights, how tall the desks are, when the light's coming in. Literally just anything you could think of, and they're going to continue studying all these different factors as time moves on. And I thought, first of all, I just wanted to share that this is kind of interesting because how many millions of people sit in an office and work, and the more that we could learn about it and to better optimize those conditions, I think that would be great. But after I was reading this, it kind of stuck with me for a little while. I was like, this is kind of an interesting way to think about just life in general, right? We all need to do our jobs, people who work in offices, but there's a right way to do it that I guess kind of gets overlooked sometimes. And I think if you could monitor all these aspects of your own life, right? If you had a private researcher keeping track of you, which I guess you could kind of be yourself, wouldn't you want to know exactly how these things are affecting you? So it just kind of made me think you kind of need to be your own researcher when it comes to you, because there's so many factors that could be affecting you.
Yeah.
And it kind of stuck with me for a little while. There's so many factors out there that we can't really control, but do have an effect on us.
It's interesting to do this in the workplace because there are two ways, or more than two ways, really, to go about optimizing, right? There is a way to optimize efficiency and output of whatever business you're in.
So, exactly, that's a good point to make. And that's why a lot of their funding, they're partnering with corporations.
Right.
Because they want to know what's the best way to do it.
Exactly. But then there's also ways to optimize health and psychology, right? And well-being. And sometimes I'm sure those two things clash against one another. And it'll be interesting to see what the corporations decide to go
do with this information, right?
Do they say, well,
let's make everybody healthy, or do we maximize profit?
Yeah.
It's like, how do you use this information? That's a good point.
Yeah, so I'm sure it'll depend on the corporation. Some are more evil than others. But no, it's true. I mean, working now in with the pool company, with the pool maintenance company, we're always trying to maximize our efficiency with, limiting the amount of trips we have to take back and forth from the truck to the pool, because that adds time on. If we can cut back on one trip per pool that we're at, and we go to 20 pools in a day,
that's 20 trips.
That's that's 20 trips times 5 minutes. That could save us 100 minutes. That's over an hour. And that's an hour that I'd like to be home,
exactly,
catching up on other things, on science news, basically. So it is important to keep those just little things in mind in your day-to-day routines, in your workplace, and in your, in your home, in your, just everything that you do, because you could maximize your efficiency or your health and well-being in ways that you didn't even think about, because it's so part of the routine.
Exactly. That was kind of the main point I wanted to make, that at the end of the day, there's a lot of stuff that people do just sort of the way things are done. A lot of stuff just happens that way, and being able to take a step back like this research is doing, you can get a lot of information on a lot of different little things and how they affect you if you take a little time out to just examine it and then move on from there.
Yeah.
So I think trying to do this in your own life every once in a while, just trying to optimize you, not a bad idea.
Yeah, certainly. Nancy Cleta makes a great point. Corporations should realize healthier workforce means less absences, more productivity, more profit. I agree with that.
Yeah.
100%. I think that even in that article, they were mentioning that we spend corporations spend billions of dollars on paying people sick leave, because
they got to do it.
Yeah, and it could be workplace related, not necessarily that they got sick from something on the job, but
just being sort of run down from whatever their tests are.
Right. If the lighting isn't proper in their office, cubicle, then
or if it's too cold or too hot, they could get
just over time that could really be detrimental, over time. So what's funny is my mom works in a medical records office, and I'm sure she would not be happy if people were futzing around
messing with the temperature.
I wonder if they have it all set up on like an automated system where it's like the desk just like rises on you while you're trying to do your work.
I'd be like, for real? Now I gotta stand up?
That would be hilarious. But I've worked in offices for many years now, and I can say that some are nicer than others.
Yeah.
Some work environments are way more conducive to getting things done than others. And
just as a last take home, I want to say, like, as you're moving forward, I think it's always important to try and optimize, as opposed to just looking for the next dollar or the next idea. It's also important to make sure that it's all running as well as it can before moving on to this and that.
Yeah, right on, man.
Yep.
Very nice. All right, guys. So that's all we have for you this week. We hope you enjoyed the show. Like we said, if you like this video, please subscribe to us and give us a thumbs up if you enjoyed it, and give us a thumbs down if you didn't enjoy it.
Tell your friends, tell your family.
Tell your friends, tell your wives, tell your kids. We'll be back next week, of course, with more science news for you. Until then, we will wish you guys another happy Memorial Day weekend, and
a good week.
Yeah, see you guys.
Thanks for watching.